Hello, my fellow mathletes, and welcome back. It's your friend Root Beer here, and I'm looking at question 24. 8 identical spheres, each of diameter 20, fit tightly in a cube of side length 40, so that each sphere just touches 3 of the faces of the cube. Okay. The radius of the largest sphere that will fit in the central space, just touching all 8 spheres, is closest to. Okay, now I make no secret of the fact that I'm not the best at 3D geometry problems. So it's, I've got to sort of visualize this, and pictures can help. One nice 3D picture can give you some good information, but it's always a nice thing as well to look at sort of pictures on the side. Three-dimensional geometry is not something that has ever been particularly stressed in the education system, at least not since I've been born. Okay, so, I think a couple people out there might be in a similar boat. And we're often a lot better at two-dimensional geometry. Well, if we just look at things, from a fixed side or, on a particular angle, we can draw two-dimensional pictures. And so that's where the math largely gets done. But what could we have? We can imagine sort of a sphere in here, and another sphere is just touching it up here. And another sphere here, touching the sides there. Another sphere here. Spheres back here. And so we sort of want one that's in the middle, touching everything. So touching this one, and the frontmost one, and this one. It's touching them all. Now, that's really, really sort of hard to see. And how much space is there is kind of tricky. Okay? Now, when I look at, or when I sort of try to imagine this in my head, and if you have some little styrofoam balls that you're allowed to bring in, ask your proctor. Don't just bring things and pull them out. You don't want to get disqualified. But sometimes you can get these little styrofoam balls, and they can help you sort of organize your thoughts. I don't have anything exactly like that. Almost everything I play with is solid cubes and stuff like that. I used to have some styrofoam balls. Anyway, relying on an aid is never a good idea, but sometimes it helps you visualize things. But if, so I imagine two balls together, and so if they're adjacent to one another, well, they don't really constrain the smaller ball that's in between them. And if they're sort of kitty corner but still on the same side, that doesn't really tell me anything about the ball. But if I take a look at sort of opposite ones, so this one and this one, now they're directly opposite. The big diagonal of the cube runs through them, and will also run through the smaller one here, who has to be touching both of them. So I think if I look sort of right on the corner, I'm going to try and draw what I think it would look like. So the corner's right there. It sort of looks something like this. And then the middle one is sort of in there, but if I draw this main diagonal here, it's going to, so we've got diameter of 20 here, diameter of 20 here, and what's the amount of space that's left here? Because I want it to want this smaller ball to touch both of them, so I have to fill this remaining amount of space. And that'll be the diameter of this smaller ball. Did they ask for diameter, or did they ask for radius? They asked for radius, so I would just divide the diameter in 2. So how can I figure out what that's going to be? Well, I think, so based just on the high degree of symmetry, that no matter how you look at this, if I'm at one corner, it looks like all the other corners. This ball's center, the small one that we're trying to put in, has got to basically be right in the middle. And this gives me an idea. If I just look at a smaller cube, okay, then this ball's center lies right on the corner. And so basically, if I look at the smaller blue cube, we've got sort of, it's almost like when you're a kid and you drew a sun up in the corner of your picture. It just, an eighth of a sphere up here, and it's just going to come in and touch the single sphere that occupies this 8th box of the larger cube. And I think that will help. Because now if I connect up this diameter, this diagonal of the cube, it'll still pass through the diameter, take up 20 there. But I can figure out this length here, and then the radius of my small sphere is going to be the same as this radius here. So, what's this diagonal of a cube? So, okay, diagonal of a cube. So these small cubes, the big cube has a side length of 40, so these will be halves, so 20, 20, 20. Basically, if I go along the bottom and then up, I can get 2 right angles, one here and one here. Or I could just jump to, it's going to be the square root of 20 squared plus 20 squared plus 20 squared. Depends on how comfortable you are in 3-dimensional geometry. So you could either do that for the whole thing, or you could say, well, let's use the Pythagorean theorem to get the length of this purple diagonal across the bottom face as square root of 20 squared plus 20 squared. And then we'll square that and add on a 20 squared and square root it to get the hypotenuse of the big purple triangle. And either way, you're going to get 20 squared, 20 squared, 20 squared, and you cube root it. So it's going to be root 3 times 20 when all is said and done. 20 squared is 400, so you'd have 3 400s, that's 1200. And if you square root that, you're going to get 20 root 3. You can get it on your calculator, but I don't think we're ready to round. So that's equal to this diagonal, this large diagonal here. And as I've already remarked, this large diagonal is split. The sphere's diameter takes up 20, and then the 2 little parts here are both equal to the radius. One of them actually is going to be the radius, but by symmetry it's going to sort of be the same length. And so, okay, 20 root 3 minus the 20 for the diagonal divided by 2 is going to be that little area R that's left. So dividing by 2, we're going to get 10 root 3 minus 10 is R. Now, none of these answers actually are exact because if we take a look, they are asking for is closest to, so I get out my trusty calculator. 10 times the square root of 3 is 17.32 something something. So we subtract off 10, we get 7.3205. Okay, and that's closest to the 7.3. And our answer to 24 is going to be B. All right, now we've got one question left to go. That's question number 25. Join me for that in the next video if you'd like to. And yeah, have yourself a wonderful day in the meantime. Take care.